So let's talk about parent functions and how we can transform them. Start with something simple that everyone should already know by now, which is linear functions, where this is just a straight line that we get here. And we use y equals mx plus b, where transformations aren't really considered in this mx plus b format, but the way that we can think about it here really is that this m here is what is going to be stretching it, which makes, again, the slope steeper, or compressing it, which would make the slope less steep. So that's kind of like the vertical stretch or compression, whereas the b value would shift that line up or down. So instead of it being, let's say, through the origin, it would go through y-intercept of 5 or y-intercept of -5. So those are kind of like the transformations. I also just quickly want to talk about the domain and range of a linear function is always going to be all real numbers because it goes on forever to the left and to the right, which is our domain, and it goes on forever up and down, which is our range. As far as absolute value, there's a little bit more to an absolute value function because there are more transformations that can happen. If we're looking at an absolute value function, first of all, the parent function should look like a v, hence the v in capital value here. So it's always going to be a v, and the parent function starts the vertex, or this point here, at the origin at 0, 0. And all of these transformations, a, b, h, and k, that changes the way that this v shape is going to look. A and b, again, are vertical stretches or compressions. So a value vertical stretch would make it skinnier v, vertical compression would make it a wider v, and a b value does pretty much the same thing, where a horizontal stretch would make it wider and a horizontal compression would make it skinnier. So A and B pretty much do the same thing, but they're considered different because of where they land in the function. If you see here, the A value is outside the absolute value, whereas the B value is inside the absolute value. The H and the K basically shift it, shift this V. They don't change the shape of it, but they just move it. So the H value moves it to the left or to the right. It is a horizontal translation. So it moves it to the left or to the right. And the thing that we want to notice here is that it is a negative sign here, meaning that, let's say, if our absolute value function was x minus 3, that's actually going to move this v to the right. The k value moves it up or down. So if you have a k value, so let's say this x minus 3, if we had plus 3, well, that would move the entire v up. And if it was subtraction, it would move that v down. So the thing about the h and the k value is it is just shifting it. It does not change the shape of the v, it just moves it. And really the kind of the trick here for the vertex, or this point here where the v starts, is basically just going to be the point hk. Wherever the, let's say this again was 3, sorry, x minus 3 and then plus 3, well, then our vertex would be 3 to the right because we'd be moving it 3 to the right from the origin, and then 3 up, which would give us our vertex of 3, 3. Now, the other thing about the a value here that is nice about absolute values is that the a value really just determines what the slope of this line here is on the right, and then the negative of that would be the slope on the left because it is a symmetrical function. The a value, just as a heads up, it can be negative, and if it's negative, well, that's going to flip the v upside down. So in this case here, if a was negative, it would flip it to look kind of like it's an arrow pointing upward instead of a v. And just know that it flips it over the point itself, right? So if we had, let's say, we were graphing it, we had the h and the k value, which moved the vertex, to the right and up to like this point here. And naturally it would be a v that goes up like this. Well, if the a value is negative, well, it would flip it down in this direction here. The reason that's important is because the b value, the way that that flips it, it does not flip it from this vertex here. The b value flips it horizontally over the y-axis. So it doesn't just flip it at the, let's say, the vertex here. doesn't flip it horizontally that way. It actually flips it over the y-axis all the way to the opposite side. The last thing about absolute value functions is the domain and range. So domain is going to be all real numbers. It still goes all the way to the left and all the way to the right. Whereas the range is only going to be some numbers, because you see here that in our original orange function at the top left here, that it does not go below, in this case, 0, because it goes up and to the right and up and to the left. So our range is only above the k value, because let's say that we had a positive 3 for our k value back here. Well, that would shift our v up, meaning the y values would only be 3 and higher. The flip side of that, no pun intended, is if we have a negative a value, well, that flips it upside down, meaning that if we have an a value that's negative, our range is going to be y is less than or equal to k, because wherever k is at, wherever that vertex is at, all of the y values are going to be less than that. If we want to talk a little bit about quadratics here, it's really similar to absolute value in a lot of different ways. There are still a, b, h, and k values, and they all do the exact same thing. Vertical stretch or compression for a, horizontal stretch or compression for b, horizontal translation or shift for h, so left or right, vertical translation for k, up or down. There's still a vertex, and the vertex is still at that point hk. So if we have some numbers in h and some numbers in k, that's going to be where that vertex or that point of the quadratic is at. The only difference here is that the line is no longer, it's no longer linear on the right side of the vertex and the left side. It is a quadratic or a parabola, so it is kind of changing forever. Kind of gives us this U shape. Same idea with the negative a and the negative b, though. It does flip it upside down for the a at the vertex, and the b value, if it's negative, flips it over the y-axis. Domain and range are also the same, where domain is going to be all real numbers, and range is going to be greater than k if a is positive, or less than k if a is negative.